we are going to solve the following quadratic equations. Two questions. How do I know I'm supposed to solve? Because there's equal signs all the way down. So we're going to find out what x is. Second of all, how do I know that they're quadratic? Because you've got an x squared. And if you have other x's, it just walks down. So x2, x1, no x. These are polynomials, so no variables in denominators, no variables under radicals, anything like that. Okay, so what we want to do first is work through this one. I would look at the notes that I posted in the module because I'm going to show you how to solve this quadratic equation using the three methods that I posted, meaning there's actually four, but we're going to squish two of them together. So the first thing we want to do is see if we can factor. If something is factorable, that's going to be your fastest way out, usually. Okay, so can I factor this down? I need two numbers that multiply to 7 that add up to 8. Well, that would be 7 and 1. Okay, so I can say x plus 7. X plus 1 is 0. And now I've got two chunks multiplied together, and my answer is 0. So I'm going to take each factor and set it equal to 0. This is called the zero product property. So I can multiply these together and get 0. That means one of them's got to be 0. So I'm going to subtract 7 from both sides. So one of my solutions is x equals negative 7. Subtract 1. One of my solutions is x equals negative 1. So we got our two solutions. We have factored. The next thing we want to try doing is completing the square. And in the process of completing the square, we are going to use the square root method. Okay? If I'm completing the square, I want all my variable terms on one side, and I want the constants on the other. So notice I subtracted 7 from both sides. So 0 minus 7 is negative 7. So I'm going to complete the square. The way I do that is I take half of what's fixed to be my middle term. So half of 8 is 4, and I square it. So 4 squared is 16. I have just created a 16 out of thin air, so you better do it to both sides. I can do anything I want to as long as I do it to both sides. So now what's the benefit of that? If I factor this, what are two numbers that multiply to 16 but add up to 8? That would be 4 and 4. So I could write that as x plus 4 times x plus 4. But I'm a lazy math person, which means I'm going to write this as x plus 4 squared. And then 16 minus 7 is 9. Okay? And what that does is this is a perfect square in algebra world. Okay? In arithmetic, 16 is a perfect square. 25 is a perfect square. 81 is a perfect square. In algebra world, this is a perfect square because you can write it as something times itself. Okay? So how do I solve this? I'm going to take the square root of both sides. So on the left side, the x plus 4 pops out. I will not forget my plus minus. And I happen to know that the square root of 9 is 3. So now I'm going to solve for x. So subtract 4 from both sides. So x equals, I get negative 4 plus 3, which is negative 1. And I get negative 4 minus 3, which is negative 7. I got the exact same answers I got up here. Okay? So we did square root method in the process because I had a chunk squared equal to something else, and I took the square root of both sides. So completing the square means I set it up so I can do this. The last thing that we're going to do is quadratic formula. So the quadratic formula says that x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to fill this thing in. Negative b, this is going to be my a. So this is a, b, and c. Okay? So my a is 1, my b is 8, my c is 7. So I've got a negative b is going to be a negative 8. Plus or minus the square root of b squared. Well, 8 squared is 64. Minus 4 times A times C all over 2 times A. So I'm going to move to the next line. This gives me a negative 8 plus or minus, and I get 64 minus 28. So 64 minus 30 is 34. But that's too many, so it's 36. So 64 minus 28 is 36, and that's going to be over 2. So this should look familiar to you from the last module. So I will now say a negative 8 plus or minus. Do I know the square root of 36? I do. And that's going to be over 2. So now I have a negative 8 plus 6 over 2, and a negative 8 minus 6 over 2. So negative 8 plus 6 over 2 is negative 2 over 2, which is negative 1. And negative 8 minus 6 is negative 14 over 2, which is negative 7. So all three methods gave us the same answer. We want to be lazy math people and use the quickest method. So looking at this, what is my quickest method? I have a chunk squared equal a number. So this is going to be square root method. If you want to factor it and bring your 9 over, you go for it. So I'm going to take the square root of both sides. I get x equals plus or minus the square root of 9. So x equals positive 3 and negative 3. You have two answers. One is positive 3, one is negative 3. This one, x squared is negative 36. So what method am I going to use? Well, this is set up as a chunk squared equal a number. So this is set up for square root method. So anytime during the process of solving a problem that I take a square root, do not forget your plus minus. So the square root of x squared is x equals plus or minus, and I'm going to go ahead and rewrite this as 36 times negative 1. Do I know what the square root of 36 is? I do. It is 6. Do I know what the square root of negative 1 is? It's imaginary, so I write that as I. So I had two solutions. One is a positive 6i, and one is a negative 6i. Okay? So those are my two solutions. So now I'm going to do this one. This one is the difference of two squares, but that's not a perfect square. So I am going to use square root method. I'm going to get this 12 over to this side. So I'm going to subtract, or I'm going to add the 12 to both sides. And now I'm going to rewrite this over here. So I've got an x squared equals a positive 12. What this would be is a 12 equals x squared. And I just flip-flopped it. Okay, so I got a chunk squared equal a number. I'm going to use square root method. So I'm going to square root both sides. Don't forget your plus minus. So I get x equals plus or minus the square root of 4 times 3. I could have written this as the square root of 6 times 2, but I'm trying to find perfect square factors. So 6 times 2 doesn't help me because neither one is a perfect square. But 4 times 3 does help me because 4 is a perfect square. So do I know what the square root of 4 is? I do. It is 2. So I have x equals plus or minus 2 times the square root of 3. So the square root of 4 is 2. The square root of 3, we're just going to leave it in the radical and leave it that way. So you've got two answers. One is a positive 2 root 3. The other one is a negative 2 root 3. So what's this one? I do not have a chunk squared. In fact, I've got x squareds, I've got x's, and I've got constants. So I'm going to try to factor this. So let's see if he's factorable. X squared minus 3x minus 10 needs to be 0, but I'm going to put my equal 0 over there. Okay. So do I know two numbers that multiply to negative 10? Your signs are different. That have a difference of negative 3. So my options would be 1 and 10 and 2 and 5. Your larger number will be negative. So 1 minus 10 is negative 9. 2 minus 5 is negative 3. That's your answer. So one of them is going to be an x plus 2. The other one is going to be an x minus 5. And those equal 0. Set each factor equal to 0. So by subtracting 2 and by adding 5, we get our two solutions of x equals a -2 and a +5. Okay, this one, what I have here is, let's see if we can figure out how this thing factors down. So I'm going to multiply my first and last and use factoring by grouping, or the AC method. Okay, so I've got a 6 times a 36, or 6 times 6 is 36. I need two numbers with the same sign that when I add them together, I get -1. Well, that's going to be impossible. Because if I start listing these factors, everything that I add together is going to be bigger. Oh, I put 3 times 6. What? I don't know how to multiply. 3 times 12, 4 times 9, and 6 times 6. If I add all of those groups together, it's going to be bigger than -1. So this doesn't work. So now I'm trapped. I must use quadratic formula. I don't have an option. So this is not factorable. It still means I can break it down. It just means my answers are going to be ugly. Okay? So I've got -b plus or minus the square root of b squared minus 4ac all over 2a, and that is going to be x. So I now have -b gives me +1 plus or minus the square root of b squared, which gives me -1 times -1 is 1, minus 4 times a times c all over 2a. Okay, so this gives me 1 plus or minus the square root of, well, 36 times 4 is 144. And then 1 minus 144 is going to be a -143 over 12. When I do the math, I find out that 143 is prime, which means the only way I can work this out is going to be a 1 plus I root 143 over 12, and a 1 minus I root 143 over 12. So this last one, I got a couple of different ways I can do it. Okay, I do know that if I add 1 to both sides, I'll get 0 equals 3x squared plus 1. One of the reasons I did that instead of dividing by 3 is it's just going to be a little bit cleaner to do it this way. Okay, so this is not factorable. It's not the difference of two squares. Okay, I can't use the AC method. I can't do anything like that. So what I want to do is, like I said before, I could have divided both sides by 3 and then taken a square root of both sides, but then I would have to start rationalizing. I don't want to do all that. So I'm going to use quadratic formula for this. I'm going to change my pen color so you can see what's going on. In this case, your b is 0, which is okay. So I've got -b, which is just going to be -0, which is 0, plus or minus the square root of b squared minus 4 times a times c all over 2a. So I end up with a positive or negative root. So 0 plus or minus. So plus or minus, this gives me a -12 over 6. Okay, and then that negative is going to be I. I'm going to use 4 times 3 like I did before, just like I did up here. So that's going to be a 2i square root of 3. So I have plus or minus 2i times the square root of 3 over 6. So now my 2 and my 6 reduce by 3. So my answer for this one is positive or negative I root 3 all over 3. Don't reduce those 3's. Okay. The next one we want to do is look at the discriminant. So the discriminant is the inside chunk of the radical. So I'm just going to use that part. Okay. If it goes negative, that means you're going to be dealing with imaginary numbers. So if this is negative, you're going to have no real solutions, which means you will have two imaginary solutions or complex. Okay? If this equals 0, your discriminant, that means this goes away. There's nothing to add or subtract. So you'll end up with -b over 2a. Okay? So that means you'll have a single solution and it is real. If you end up with something positive underneath this radical, that means you'll have to take negative b plus that mess and negative b minus that mess, which means you will end up with two solutions and they are both real. So let's just do the discriminant. We're not going to follow through. We just want to know what our answer is going to be like. So I'm going to use just this part under the radical. So b squared minus 4ac. So in this case, I'm going to have a 4 squared minus 4ac, which gives me 16 minus 28, which is negative. 16 minus 28 is a negative 12. So I have a negative answer. If your discriminant is negative or less than 0, you will have two solutions and they are imaginary. And honestly, we're going to change that. We're going to say complex. Okay? So complex. We can say imaginary, but that's part of the answer. So we could say two complex solutions or two imaginary solutions. So let's do this one. I just want to know the solution type and how many. So I have I've got a b squared, which is negative 30 squared, minus 4 times a times c. So I get 900 minus 36 times 25. I don't know what that is 900 minus 900. So I get a 0 for an answer. 0. If your discriminant is 0, you're going to have one real solution. Okay, so when I find this, I'm going to have one real solution. Now let's look at this one. I've got a b squared minus 4 times a times c. So I get 1, and then a negative 4 times a negative 2 is 8, times 6 is 48, and that's going to be positive. Okay, so 1, and then a negative 4 times a 2 is a positive. 8 times 6 is positive 48, so I get 49. I get a positive answer. Okay, which means, what do you have? If you get a positive answer, you're going to have two solutions and they are real. Okay?